Okay, let's unpack this. Today we're doing a deep dive on just one component, but it tells a whole story. It's the Kramer CP-AOCH 60F-66.
Right.
It's a 66-foot active optical HDMI cable. And our mission here is to really understand the engineering that lets a 4K signal travel that far without, falling apart.
And that's the key question, because if you try to push that much data, we're talking 18 gigs a second down a long copper wire,
It's not going to work.
it just becomes an antenna. It picks up noise, the signal degrades. So
Yeah.
you have to move to a hybrid of fiber and copper.
So that's the only way to fight against that interference and just the sheer distance.
It is. It's how you win that war.
And the performance you get is, well, it's pretty much perfect. The spec sheet confirms that 18 gigabits per second data rate, which gives you 4K at 60 hertz, and with full 4.4.4 color.
And doing that over 66 feet just a few years ago would have required some serious expensive hardware, signal boosters, all of that.
So the fiber is what makes it all possible.
It's the only way. And what's interesting is the choice of OM3 fiber. It's a multi-mode fiber, which tells you they're balancing performance and cost. It's perfect for inside a building, but you wouldn't use it to cross a city.
You mentioned it's an active cable. That's the conversion part, right? The little brain inside the connector doing the work.
That's it exactly. The spec mentions a 4-channel, 850 nanometer VCSEL array.
Okay, that sounds like a lot of jargon. What does that actually do?
So that tiny chip is the brain. It takes the electrical HDMI signal, turns it into pulses of light, sends it down the fiber, and then another chip at the other end turns it back into electricity. It all happens inside the cable head.
And it happens with almost no signal loss.
Precisely. It kills degradation before it can even start.
But with all that tech, you'd expect it to need a power brick. I know installers hate dealing with those.
Oh, they do.
The source says it only consumes, what, 250 milliwatts max? Is that low enough to just run off the source device?
It is. That's the really practical magic here. 250 milliW is so low that it pulls all the power it needs right from the HDMI port itself.
So no external power required.
Never.
Period. You just plug it in. It makes the install so much cleaner.
And it's physically easy to work with too, right? It's thin.
Super thin, yeah. Just 4.5 millimeters, and the bending radius is 20 millimeters. So you can actually get it around tight corners without having to, tear up the drywall.
So we have the speed, we have the power, and the size. What about the protocols? Does it speak the right language for let's say, a high-end control room?
It supports pretty much everything you need. It's totally transparent to HDR, HDCP 2.2.
That's the copy protection stuff.
Right, the stuff Netflix cares about. It also handles ED and CEC control signals. And crucially, it supports wide color spaces like BT Time 2020, which is essential for the best HDR displays out there today.
And for the big commercial jobs, I saw one detail that I know is a huge deal. It's Plenum rated. Yes, that is non-negotiable. It means the jacket is fire resistant, so you can legally run it through air handling spaces, like in a drop ceiling.
Without that, you can't even get the job signed off by an inspector.
You're dead in the water. Absolutely.
Wow.
And what's fascinating here is they even thought about the physical connection point. They used these 24K gold-plated K-lock connectors.
So they're corrosion resistant.
Corrosion resistant, and they provide a much tighter, more secure physical connection so the cable can't accidentally get pulled out.
So when you look at the whole package, this one cable, the CP-AOCH 60F-66, it really just distills all this complex optical engineering into a simple plug-and-play solution.
It really does.
It handles the insane data rates and the long distances that copper just can't.
And if we connect this to the bigger picture, the wide adoption of these super efficient, low-power hybrid cables, it fundamentally changes how architects can even think about video infrastructure. Well, you no longer have to plan for power outlets or repeater closets every 50 feet. The constraints of distance and power are kind of solved. This raises an important question. Now that those major constraints are gone, thanks to tech like this 250 milliwatt cable, how are architects and designers going to push the boundaries of where they place displays in the next generation of buildings? Think about that.